Hello everyone. In this video, we are going to discuss about the detailed classification of data structures. Data structures are basically classified in two types, primitive data structure and non-primitive data structure. In primitive data structure, again, we have a basic data types like integer, float, character, and Boolean. Non-primitive data structures are further classified in two types, linear data structures and non-linear data structures based on its organization. In linear data structure, again, we have a static allocation as well as dynamic allocation. Based on the memory allocation, we have a classification. And array is the best example for static allocation. In dynamic allocation, linked list, stack, and queue. Stack and queue can be implemented with the array also. That is the static allocation. In non-linear data structure, tree and graph. So now here we have a basically classification in two types, that is the primitive, non-primitive. Primitive, it gives the identity primary level of the system. Non-primitive, it is non-primary level of the system. What it means here, in case of the primitive data structure, once we are declared any of the data with its basic data type, it will be identifiable in the system in its low level architecture. Means these are having the fixed identity and system directly identifies what is the information fed by the user. Whereas in case of the non-primitive, the system cannot identify the given information. The given data will be getting its identity again by using the primitive data type as an interface. So in case of the primitive, primary level identity of the data it will comes. Whereas in case of the non-primitive, it is a non-primitive data structure is derived from the primitive data structure. Whatever the data types we are specifying with the non-primitive, they will be getting their identity by the primitive data types. For example, if it is given the int A means that allocation of the 1 byte allocation. That is allocation of the space, it will be fixed, that it may be of the 2 bytes or 4 bytes. Float X means X is the name of the variable and size of the float, it will be 4 bytes. Character, it is 1 byte. Boolean, either it is true or false. That is a 1 bit of allocation. Like that, each and every type of the data will be having its fixed allocation, that is of the primitive data structure. In case of the non-primitive, it is not having its identity. Identity through the primitive it will comes. For example, we have a array. It is a non-primitive data type. Int A of 10. A of 10 means that here we have a 10 allocations. And by including all the allocations, we have a single variable name A it will be given. And here we have a integer data type means each allocation it will be allocated with the 2 bytes. Like that, here we can use the multiple values for the specified data type. Whereas in case of the primitive, we have a single value for the specified data type, it will comes. And this operation on the primitive type will be very simple. Whereas the operation on non-primitive, it will be complicated as it will stores the multiple values in the typical data type. So here we have a linear and non-linear based on the organization, whether the allocation it is a consecutive or non-consecutive. We have a linear allocation as well as non-linear allocation that we can notice here. In case of the array, we have a consecutive allocation, linear data structure it is. Whereas the linked list, it is having the consecutive allocation, linear data structure, and stack as well as queue, stack and queue. These are the linear data structure. In every data structure, we can notice there is a consecutive memory allocation. It will be taking, that is in the sequence. And non-linear data structure, one of the best example is a tree. In tree, we have a that files data, it will be represented with the node, and one node to another node connection, it will comes with the edge here. So here we have a formation of this structure. It is not in the consecutive mode. The data will be dispersed here and there, and these data are logically connected with the edges. So now it is the tree. If there is one more edge, it will be added. Here, from here to here, if I take the edge, this, it will be forming the cycle. If this tree, it is having the cycle, then it is called as a graph. That tree is a non-cycling, that without cycle it will comes, whereas a graph is a tree with cycles it will comes. So here we have a array in consecutive memory allocation. We have a 0, 1, 2, 3 always allocation. It will take from 0 and last number of for n number of elements, last allocation will be n minus 1. Consecutive allocation it will take. So linked list. Linked list means that information it will stores in terms of the node, and node will be classified in two types. One for the information, another for the link. Two partitions we can get here. And this link, it will be connecting to the next node. And again, that each node, that is information, it will be having its partition, that is for the information itself as well as link. That link, it will be linking, it will be pointing to the next information. Like this, to look, it is not in the linear, but logically, it will be having the linear structure in order to process. And here we have a queue. Queue is a linear data type, data structure in which we have a insertion and deletion will be taking from the separate ends. Insertion from front end, rear end, whereas deletion from the front end it will take. So here we have a two ends we can get. This it is a last in, uh, last out, first in, first out. Like that we have a stack. Stack will be having only one end here. Insertion also we are taking from the same end and deletion also from the same end. That's what, which one we are inserting last will be removed first. Last in, first out. Otherwise, first in, last out it will comes. So stack, the top will be the pointer. It will goes on pointing to the next location when we are inserting the values. So this is of the nonlinear data structure. And these we can take here linear data structure, static and dynamic allocation. Static allocation means it is a fixed allocation. Once the allocation in array is taken, that it will be fixed. We are not going to change 2 bytes, 2 bytes, 2 bytes it is taken means it is fixed for each and every element. Whereas dynamic allocation means, suppose now we are given the size 1, 2, 3, 4, 5. Array of size 5 it is given means 5 size it will be fixed here. And like that here we have a linked list. It is the best example for the dynamic allocation. So here we don't know how many information we are going to insert. Now it is the 4 information. Again we need to insert fifth one, sixth one. Automatically it will goes on creating the node and linking with the further. When it is deleted, it will goes on delinking. This is the process. It will be continued here in case of the dynamic. That is the allocation of the memory, allocation and deallocation. It will be automatic here. So like this here we have a classifications of the data structures will be coming in the different types. And this related theoretical information will be given in the slide. Primitive data types identified and interacting in primary level of the system, but non-primitive type are derived from the primitive types. Thus, they are having their identity in the primary level of the system. And here we have a complexity. Complexity, non-primitive, they are not having their identity in the primary level. Then complexity, with respect to the complexity, primitive data structures are simple here in order to implement, whereas non-primitive complicated. And mutability. Mutability means changing, that which it will be having its changeable property and non-changeable property. That is, primitive is not changed, it is fixed, whereas non-primitive it will be changing. Storage, that it will be very simple in case of the primitive. In case of the non-primitive, it will be complicated. This is all about the classification of the data structure. So further information, we can proceed with the further videos. Till then, goodbye.